Hello students, in this particular class we are going to discuss regarding the special problem on frames using slope deflection equation. So here first the previous step whatever we incorporated in case of beams, the similar steps we are also going to incorporate in case of frames. First whether we have to check the thing is the given frame is sway frame or non-sway frame by looking the each joint and kinematic indeterminacy. So we will move on to step by step. In step 1, kinematic indeterminacy. When you are doing kinematic indeterminacy of frames, observe each joint, not the load conditions. Observe each joint. I already explained that each joint may possible displacements of 3. So here fixed. Here A, B, C, D. So A and D are fixed. Therefore, there is no displacements at A and D. There is no displacement at A and D. Because of this fixity, we are assuming axially rigid also. The horizontal displacement will not occur in this particular frame. Because of this fixity, this member will not allow to deflect in horizontal direction. Hence, this is 0. Because of this fixity, the vertical is 0. Because of this reaction, here we are getting 0 displacement. The only possible displacements are theta B and theta C. Therefore, in the given problem, the kinematic indeterminacy equal to theta B and theta C. So this is a non-sway frame. The column is not deflecting. Hence, it is a non-sway frame because here D is fixed and A is fixed. Because of this fixity, because of D fixity, DB will not move. Because of A fixity, AB or BC will not move in horizontal direction. Hence, the given frame is a non-sway frame. The only indeterminates are theta B and theta C. This is the first step. Next, step 2. Step 2. In step 2, FEM, fixed end moments. Fixed end moments. FEM, fixed end moments. So first MFAB equals minus WL square by 12, that is minus 20 into 4 square by 12, minus 20 into 4 square by 12,
minus 26.67,
minus 26.67 kilonewton meter. Similarly, MFBA, that is plus WL square by 12, 20 into 4 square by 12, you are getting plus 26.67 kilonewton meter. ABBA is over. Next I am coming to BCE. Therefore, MFBC equals minus WAB square by L square,
minus 28.8,
minus 40 into A distance is 2, B distance is 3, 2 into 3 square by 5 square by 25. We are getting
28,
minus 28.8 kilonewton meter. Minus 28.8 kilonewton meter. Similarly, MFCB equals plus WBA square by L square. Therefore, 40 into 3 into 2 square by 5 square. 40 into 3 into 4 divided by 25.
19.2.
19.2 kilonewton meter. 19.2 kilonewton meter. Next I am coming to this span BD. So MFBD. See, MFBD, this load moving in the anti-clockwise direction. Therefore, the fixity will develop in clockwise direction. Therefore, plus WL by 8. Therefore, plus WL by 8. 20 into 4 by 8. 20 into 4 by
minus 10.
8. 10 kilonewton meter. This is plus 10 because if you consider the span BD as fixed, you are having the load in this direction, it is rotating in anti-clockwise, the resisting is positive. If you consider this rotating in clockwise, the resistance is negative, reverse. Therefore, MF dB is minus WL by 8. So minus 20 into 4 by 8 equals minus 10 kilonewton meter. This is D, this is B. So MFdB is negative. MSdB is negative. MFBD is positive. MFBD is positive. Clear? This is regarding FEM. The next third step is SD equation. Slope deflection equation. This is a non-sway frame. So delta factors we have to ignore. Therefore, the final equation is MAB equals MFAB plus 2EI by L into 2 theta A plus theta B plus or minus 3 delta by L. But here, because of non-sway, delta factor is 0. Because of non-sway, this is a given frame is non-sway frame. The given frame is non-sway frames, and also A and D, and also theta A which is equal theta D is 0. Why? Because both supports are fixed supports. Both supports are fixed supports. Fixed supports will not allow any kind of deformations. Hence, both are 0. Here, theta A is 0 because fixed. So, MAB equals MFAB is minus 26.67 plus 2EI into length of span is 4 into theta B. We are getting MAB equal 2 by 4, 0.5 EI theta B minus 26.67. Say equation number 1. Similarly, MBA equals MFBA. MFBA is 26.67 plus 2EI by length is 4 into 2 theta B plus theta A. But theta B is there, theta A is 0 and delta is also 0. Because this is fixed. Because theta A is fixed. Hence, the rotation is 0. We are getting MBA as MBA equal to the 4. Therefore, 4 by 4 is 1. EI theta B plus 26 plus 26.67. Say equation number 2. Next, we move on to second span. That is BC. MBC equals MFBC. MFBC is minus 28.8 plus 2EI by L. Total length is 5. 2EI by 5. 2 theta B plus theta C. Delta non-sway. Don't consider the delta. Hence, you just simplify this. MBC equals 2 to the 4. 4 by 5. What is the value of 4 by 5?
0.8.
0.8 EI theta B plus what is the value of 2 by 5?
0.4.
0.4 EI theta C minus 28.8. Say equation number 3. Next, MCB equals MFCB. What is the value of MFCB? 19.2 plus 2EI by L. L is 5 into 2 theta C plus theta B. 2 theta C plus theta B. So we are getting MCB equals, first I am writing theta B value. Therefore 2 by 5 is 0.4. 0.4 EI theta B plus 0.4 EI theta B plus 2 to the 4. 4 by 5 is 0.8. 0.8 EI theta C plus 19.2. Say equation number 4. Equation number 4. Next I am coming to apply for large span BD. MBD equals MFBD. What is the value of MFBD? MFBD is plus 10 plus 2EI by length. What is the length? 4. 2EI by L into 2 theta B plus theta D. But theta D is 0 because fixed. D is fixed. Hence theta D equal 0. So we are getting MBD equals 2 2s are 4. 4 by 4 is 1. EI theta B plus 10. Say equation number 5. Say equation number 5. Next MDB. MDB equals minus 10. MFDB. MFDB value is minus 10 plus 2EI by length. Length is 4 into 2 theta D plus theta B. Theta D is also 0 because fixed. Theta D is fixed. D support is fixed. So we are getting MDB equals 0.5 EI theta B minus 10. Equation number 6. Equation number 6. Once we apply SD equation, the next step is joint equilibrium condition. Here we are having only theta B, theta C. Hence joint equilibrium we have to consider at joint B and joint C only. Joint A and joint D are fixed. We are not having any joint equilibrium conditions because the joint is already in equilibrium. Hence consider joint B. If you consider joint B, please observe here. If you consider joint B, we are having BA, BC, BD. When you are applying joint B, we have to take summation of all three members. All three members at joint B, MBA plus MBC plus MBD equals 0. MBA plus MBC plus MBD equals 0. What is the value of MBA? MBA value is EI theta B plus 26.67 plus what is the value of MBC? MBC 0.8 EI theta B plus 0.4 EI theta C minus 28.8 minus 28.8. What is the value of MBD? MBD here plus EI theta B plus 10 equals 0. This is nothing but equation 1. It is nothing but equation BA. BA means equation 2 plus 3 plus 5. Equation 2 plus 3 plus 5. Finally, first you take theta B. 1 plus 8, 1.8 EI theta B plus 1 plus 1 plus 1, 2.8, right? 2.8 EI theta B plus 0.4 EI theta C equals minus 28.8 plus 10 minus 18.8 plus 26.67.
7.87.
You take on
Minus.
you just take on right hand side, it will become minus
7.87.
7.87. Take equation A, R1. Take A, no problem. Equation A. Now joint C. Joint C. At joint C, MCB equals 0. MCB equals 0. MCB equals 0 is matlab only this one. Directly we are getting 0.4 EI theta B, 0.4 EI theta B plus 0.8 EI theta C equals minus 19.2. You are getting, see, constants theta B, theta C and constant value. So solve equation A and B. Solve equation A and B. We are getting unknown values of theta B and theta C. That is your next step. Fifth step. Determination of unknowns. That is theta B and theta C. So solve equation A and B. Solve simultaneous equation A and B. You are getting theta B and theta C. What is the value of theta B?
0.67 EI
divided by EI. And what is the value of theta C?
minus 24.33 EI
divided by EI. Just solve this equation A and B. You are getting this answer. Once you got unknowns, the next step is very, very simple. You just substitute this value in step number 3, slope deflection equation. You are getting final moments. So last step is final moments. For final moments, MAB. Substitute above unknown values in step number 3. Right? In step number slope deflection equation 3. Step 3. So what is the value of MAB? You just substitute here 0.5 EI multiplied by 0.6 by EI get cancels, minus 26.67. How much?
minus 26.33.
Minus 26.33 kilonewton meter. Minus indicates this is anti-clockwise. Next, what is the value of MBA?
27.34.
27.34 kilonewton meter, which indicates positive moment. What is MBC? MBC
minus 38.00.
minus 38.0 kilonewton meter. Minus 38 indicates anti-clockwise. What is the value of MCB?
0.
MCB, simply support 0. Simple support is there 0. Next, what is the value of MBD?
10.67.
10.67 kilonewton meter. So 10 is positive, so it is clockwise. MBD, so the last is MDB. What is MDB?
minus 9.66.
Minus 9.66 kilonewton meter. Minus indicates anti-clockwise. These are the values we are getting from step number 3. Just substitute the theta B, theta C values in the respective places in equation 1 to equation 6. You are getting these answers. Positive value represented as clockwise. Negative values are represented as anti-clockwise. The last important step is BMD. For BMD, just consider this frame A, B, C, D. Now you just observe over here. What is MAB? Anti-clockwise. Present anti-clockwise. What is MBA? Clockwise. What is MBC? Anti-clockwise. Here 0. What is MBD? Clockwise. What is MDB? Anti-clockwise. So please observe here, whatever the arrowhead, this is called compression and this is tension. Arrowhead is called compression, another end is tension. Compression, tension. See, always plot BMD on tension side. Always plot bending moment value on tension side. Now you just easily draw the required bending moment as just observe here. What is MAB? 26.3633 tension side. This is 26.33. A, B, C, D. What is MBA? 27.34 tension. What is MBC? 38, right? MBC is 38. This is 27.34, and another once again this is 38. Here 0. Thing is very simple. First join this AB. You join AB. Next you join BC. Join BC. Straight line. Join BC. This is 38. Next, what is BD? 10.
10.6.
So tension side is this 10. What is DB? Anti-clockwise. Tension side is this 9. Join this 9 to 10. 9 to 10. This is 10. This is 9. Join this. This is regarding final moment. Now draw free BMD. How to draw free BMD? AB span, UDL. Draw parabola. This value is WL square by 8. Next, point load, draw triangle. And this is eccentric point load. Therefore, this value is WAB by L. Next, you are having triangle. And this value is WL by 4. Finally, just shade the separate areas. This is regarding BMD. So I hope getting how to solve this simple problem. So the very basic steps is kinematic indeterminacy. The next step is FEM. The next step is slope-deflection equation. Afterwards, you have to apply joint equilibrium condition. Afterwards, solve simultaneous equation to get unknowns. The next step is final moments by substituting the unknown values. Finally, how to draw BMD in frames. This is very important problem. Several times asked in video examinations. Please be careful while you are solving this kind of problems. I hope you are getting how to solve this important frame problem subjected to non-swaying. Thank you for listening.